Welcome to National Instruments Webcast Wednesday. Welcome to National Instruments Webcast Wednesday. If you wish to interact with us, you can ask technical questions. Before we begin, let me introduce you to the process of interacting with us during the course of the webinar. At any point of time in the session, if you are facing any technical difficulty or have a doubt relating to the content of the session, please feel free to send it to us through the chat window, which you'll be seeing on your screen right now. Our team will be glad to resolve these problems or answer your doubts. In order to maximize your webcast experience and have a learning experience free of glitches, we are offering two audio options. While you see the presentation on the screen, you can choose to listen to us through either voice over internet protocol. This simply means you receive the audio at your end through your computer speakers. Adjust the volume of the speakers for a better learning experience. If you are on a slower internet connection, you might experience a certain lag or a broken audio reception. In this case, we recommend that you listen to us using our toll-free number. You can dial this number from your mobile phone for free of cost, and you'll start receiving an audio from your phone line. The phone number is 1-800-425-4061 followed by the PIN 507248#. For attendees outside India, it's 914423702370 followed by the PIN 507248#. So today we'll be talking about LabVIEW and Multisim CoSimulation. My name is Divya and I'm an Applications Engineer with National Instruments India. So what is Multisim? Multisim is a circuit design solution where you can simulate the circuits and see their performance in real time. So at the heart of National Instruments circuit solution is Multisim. It's an analog digital and power electronics teaching environment. It's powered by simulation, and it means that anybody can interact with the circuit in a very intuitive way and immediately see an impact on what changes they make in a particular design. So it's basically a teaching solution for electronics education, and you can basically visualize how the circuit is. So it has easy to use analysis as well as interactive measurement instruments. So something that's unique about Multisim is that it had specific development done, so it extends all the way from analog circuits to power electronic circuits, and also it also includes the digital elements in between. This means that it can be used through all stages of engineering education, right from first year to the fourth year, and it's very easy to use. And I'll just be showing you a quick demonstration of what exactly Multisim is. So Multisim is an integrated schematic capture, simulation, and analysis environment. It has advanced analysis tools. So you can simulate your circuit, you can pull out a DC transient analysis, an AC analysis. You can plot a Bode plot as and when you're simulating the circuit. You can see how the actual circuit behaves before you give it out to your manufacturer to burn it on a PCB board. And the advantage of having Multisim is that it has 26,000 plus components from all leading all leading device manufacturers. It also includes intuitive simulation and interactive instruments as well as spice analysis. And Multisim, whatever circuit that you design in Multisim can be routed to Ultiboard, our national instrument solution for layout and routing environments. So let's just have a quick look at what the Multisim platform is. So the features of Multisim platform include the interactive analysis models where you can do AC or DC analysis and fully analyze the circuit response based on whatever changes that you made. It also has graphical schematic capture, very similar to what you see in LabVIEW. So this graphical interface allows you to build a circuit as and when you like it. It has a comprehensive component library of over 21,000 components, which incorporates industry standard spice models. It includes virtual instrumentation where you have soft front panels for different kinds of instruments and you can physically see what's exactly happening. And it also has 3D breadboard visualizations where you can visualize how the breadboard looks like and place different kinds of components on this particular breadboard and practice how this can be done. So what exactly is the benefit of integrated capture and simulation that you can do with Multisim? It prepares you for simulation that is as simple as drawing a circuit on a particular system. You have different kinds of animated parts which you can pick and place. You have virtual instruments, as we just spoke about, as how you can open up soft front panels of different kinds of instruments. You can also do analysis. You can also do pull out analysis of different kinds of instruments and see the analysis of the circuit as a whole. Are all of you able to hear me right now? Can you just say in the chat window that you are able to hear me? So Multisim makes an effective utilization of time when you're trying to see how schematic the circuit actually is. So where does Multisim fit in the design process when you're actually trying to test out your circuit? So first thing that you do is you select the parts. You select what components that you're going to use, the capacitors, the resistances, or the inductors, the chips, the ICs, the op-amps. What is it that you're trying to use in your particular circuit and what is your circuit supposed to do? Next, we go to NI Multisim where we capture the circuit and simulate the circuit and see the expected behavior of that particular circuit, where you can do any kind of analysis based on your requirements. So if you need a Runge-Kutta analysis, you do the same for it. The next part is you will port from Multisim to Ultiboard, where you do this the layout, the PCB layout of all the components that is there. And once this is done, you can verify it using LabVIEW along with your DAC. So what we're doing right now is we'll just be showing you how do we do capture and simulation with NI Multisim and interact with the same using LabVIEW where you can give input and output parameters. So let's just have a look at what a Multisim GUI is like. So you have organized menus very similar to how we had it in LabVIEW, where you have where you can view different components very easily. You can zoom in, you can zoom out. You have quick access toolbars to place different kinds of components to run the simulation, to pause or stop the simulation. We have the design toolbox where you can place different kinds of components on your workspace. We have the spreadsheet view where you can see what are the different kinds of components that you have placed in the form of a text. And then you also have a resizable workspace which you can scroll up and down and you can see the entire area. So the next part we'll be talking about how LabVIEW interacts with Multisim itself. So LabVIEW interacts with Multisim using ActiveX internally. And if Multisim is capable of producing AC analysis and transient analysis, LabVIEW is also able to do the same. So here we'll be just talking about what is CoSimulation. CoSimulation, you build your analog circuitry on Multisim, but you give the digital control from LabVIEW. So here you have cycle-by-cycle interaction between LabVIEW and Multisim. So the analog circuitry does the processing and gives it back to LabVIEW for display. LabVIEW gives the signal that you're trying to process to Multisim itself. So you use the control as well as advanced signal injection or analysis is done from LabVIEW. Now, how do we do co-simulation in LabVIEW? So we do co-simulation using the control design and simulation palette. So the Multisim GUI is located within the simulation palette itself. You use something called as a control and simulation loop, where you can place this Multisim controls and Multisim design tool there, choose the particular Multisim file, and then interact with it. So here in co-simulation, using an external model which you're trying to interface with. So, and we have something called as a Multisim node which calls this particular external model. So the Multisim node is a maximum of 22 terminal unit where it has a large number of scalar inputs as well as outputs. And you have to give in double precision float data to this particular Multisim node. So you can change the Multisim simulation settings from LabVIEW, which is saved with the file. These simulation settings might include any relative error tolerance or so on and so forth. So what will you be doing in co-simulation? The first thing that you'll be doing is setting the connectors which designate what LabVIEW terminals is it that you're trying to interact from or to. So these connectors is what you're giving and it's an input from LabVIEW. So if you create a circuit, the input and output connectors on your circuit is what you would interact with from LabVIEW, which is what you give the control or indication from. So basically, if you have co-simulation, this is the control and design loop that you have placed on your block diagram. The Multisim node, again, which you have placed on your block diagram. And these are the inputs and outputs. So these inputs and outputs port directly to the blocks that is there within Multisim. And it interacts with that particular circuit in Multisim. So now I'll just be showing you a quick demo of how LabVIEW Multisim co-simulation can be done. So this is the Multisim workspace that I just told you about. This is the workspace. Here you have all the toolbars where you can place the different kinds of components. And here you have the analysis tools like the function plot or body plot or the function generator as and when you like it. So here I'm just going to try and create a RLC circuit where I'm trying to see the behavior of a particular RLC circuit. So how do I do this? If I just want to create an RLC circuit, all I have to do is right click and select place a component. So this shows the master database. So master database contains different kinds of components, more than 26,000 components, which all have different kinds of groups. So you have sources where you can talk about power sources, signal voltage sources, current sources, control voltage sources, and so on and so forth. We also have diodes, have transistors, where you can see the different kinds of transistors. You can choose the transistors that you wish according to your application. Similarly, we can also do microcontroller simulation, MCU simulation, where you can choose a particular PIC controller or 805X controller and place it on your workspace. You can also choose any particular NI components. You can simulate an M series stack and an E series stack, and you can place different kinds of connectors as well. So as here, I'll just be simulating an RLC circuit, a non-ideal RLC circuit, and I'll be porting this to LabVIEW. So first, I place a source. I'll place a voltage controlled voltage source, which is a voltage controlled voltage source, and I will place it on my workspace. So I just right click and select OK, and I can just place it on my workspace right now. It again asks me for any other component that I wish to place. So I choose basic, and I will choose non-ideal RLC, where I'll be placing a non-ideal capacitor, inductor, as well as resistor on my workspace. And I'll also have to place a ground at this particular point, so I will choose a ground from here. Now, if I want to make connections between these different voltage source as well as the R, L, and C, it's very similar to LabVIEW. All you have to do is just click and drag. So here I'm connecting the voltage source with R1, R1 with C1, with L1, L1 with C1. Now here I have to place connectors for LabVIEW to interact with this particular circuit. So the first thing I'll be doing is placing a connector on how much voltage that I'm trying to inject into the circuit. And I also want to see what the output is at that particular circuit. So I'll place a hierarchical connector at this point of time. So all I click on is place connector, hierarchical connector. So I place this particular connector here. I can click on the connector and press Ctrl R to rotate the connector. Now I'm connected to the particular voltage source. I place another connector because I need to see what the output is. So this is my entire circuit that I'm trying to simulate. I'm trying to simulate a simple RLC circuit. Now to see how it looks, to see the inputs and outputs in terms of LabVIEW, first thing I have to do is go to View, LabVIEW CoSimulation terminals. So this particular CoSimulation window appears. Here you can change the input and output settings. So IO1 is my input which I'm giving to that particular circuit. So I rename it to be voltage in. And I set this to be a input. Similarly, IO2 is my output, so I rename it to be voltage output. And I rename this to be output. So here you can see the Multisim design node which is there in the VI. So this particular VI would appear when you link the Multisim node in LabVIEW to this particular Multisim design file. So now I just save this particular design file. So I save it as design1 file. Now I just open up LabVIEW. So this is my front panel and block diagram within LabVIEW itself. If I want to interact with this particular design file, the first thing that I have to do is use the control and design and simulation palette. So in this particular palette, you can interact with this particular with Multisim. So I place a control and design simulation loop here, and I choose an external model. So here I can click on the external model and I choose the Multisim design. So I can place this particular Multisim design node on my block diagram. And it asks me to select the particular Multisim design file that I'm trying to simulate. So here I enter the path where I have saved my particular design file. So I've saved it on my desktop, so I choose this particular desktop. Now you can see it selects the particular voltage in and voltage out are inputs and outputs for this particular design. Now if I want to stop the simulation in this particular loop, I have to use something called a stop simulation, and this occurs in utilities. So I place this halt simulation download on my control design and simulation loop, and I create a control for it. So this stops the simulation when I require it to stop. The next part is what I'll do is I'll create a slide control on my front panel. This gives the input voltage that is required to my Multisim design file. So I'm giving this slide as a voltage input. I'm trying to simulate how it would react to that particular voltage input. Now I want to plot this voltage output onto a graph. For this, I'll have to use something called as graph utilities, where I simulate the time waveform here. And this has one particular input. So I'm trying to plot both the input as well as the output characteristics. So I build a 2D array. So this is the input I'm giving to my waveform chart, which I've placed on the front panel. Now I can double click on this particular waveform chart. I set the properties. So I set this to 4 digits of precision. And I deselect auto scale and I set it to maximum of 0.25. I also changed the settings of this particular simulation parameters, where I changed the initial step size from to 1E05. And say OK. So now I try to run this particular simulation. So you can see that the simulation is running. You can see that there is a variation between the inputs as well as the outputs. So as and when I'm changing the inputs, you can see the variation in the input and output parameters. So what is LabVIEW doing? LabVIEW is giving an input and you're seeing the voltage output on the waveform chart. So you can see there are small variations which the circuit sees when there is a change in the particular input, which we saw as spikes. So let's have a short case study on how Multisim and LabVIEW CoSimulation has been done. So College Park Industries used NI Multisim as well as LabVIEW to simulate and test a portable device to measure the human gait. Here, they were trying to study human locomotion of amputees using prostheses and NI Multisim. So basically, they fitted a man with a prosthesis. They fitted him with this particular device, which was earlier tested and simulated using NI Multisim as well as LabVIEW. So this concludes our Webcast Wednesday presentation. If you want to extend your Webcast Wednesday learning experience, please go to an LabVIEW enabled, the NI India online community. And it's a single network of students, industries, and professionals and academicians coming together to create and discuss and exchange and share resources to generate content and applications as well as NI technologies. So if you watch the previous episodes of Webcast Wednesdays, you can get your queries from the sessions and LabVIEW result and participate in the weekly contests on our community. So keep watching the recording of this session and participate in the contest of the week on www.labviewenable.in.